All right, guys, let's take a look at our free body diagram, homework number 1. So the first problem we have here is an object lying motionless. Well, motionless right off the bat is telling us that this is experiencing balance forces. What forces are acting on this object as it lies motionless? Well, we always know that gravity is acting on the object, and then we can see that there's a surface right here. So this surface is going to supply a normal force. So if I were to draw the free body diagram of this object, I would have gravity pointed downward and force normal pointed up perpendicular from that surface. And it would look something like this. Let's move over to our next problem over here, number 2. Object slides at a constant speed to the right without friction. Key word here is without friction, also constant speed. Constant speed again is telling us balance forces. This object is flat on the ground, so we know that force normal is present. We also know that force gravity is there as well. So this is also going to look like our problem number 1, where we have force gravity pointed down and force normal pointed up. Moving along, let's take a look at number 3. Object moves to the right and slows down due to friction. So slowing down is telling us unbalanced. And it's also telling us that there is friction in this problem, so that's important. So if I go ahead and I list these forces, I always start with gravity, then I see there's a surface, so there's force normal, and the problem tells me that there's force friction. I don't see any ropes, I don't see anything being applied to it, so I don't see any tension or any force applied. So drawing this free body diagram, I have my box right here. I have force gravity pointing downward, force normal pointing up. I see that these two are the same size because it's not accelerating in the y direction. And then I have force friction moving back to the left. How do I know force friction is moving to the left? Well, this diagram right here is showing me that my box is moving in this direction. These are like little air trails behind the box. Number 4, object slides without friction. So if we look at this problem, we can see right here that it's showing some sort of speeding up because these lines are getting further and further away from each other. So this is going to be unbalanced as well. We're going to go ahead and start with force gravity as one of the forces that we list, and then force normal as well because there's a surface. No ropes, no other forces being applied. This is it. We're going to put force gravity pointed downward. And then we have force normal pointed perpendicular from that surface. So in this case, force normal is now at an angle because perpendicular means that it forms a 90-degree angle with the surface. Number 5 says static friction prevents sliding. So this box is still and at rest, therefore forces are balanced. And it also tells us that friction is present. So listing our forces, we have gravity, we see a surface, we have normal, and then we also have force friction. So for my free body diagram, I have gravity pointed downward, normal pointed perpendicular. So this again is at an angle. So normal is going to point up at an angle. And then I also have friction here. So friction is going to point opposite the direction of motion. And in this case, it would be parallel to this surface. So friction is also at an angle. And you're going to notice that friction and force normal form a 90-degree angle here. This will always be the case when an object is on an angled surface, or in other words, an inclined surface. Number 6, an object is suspended from the ceiling. So suspended meaning at rest, therefore the forces are balanced. Start with force gravity like we did before. But this time we're going to see that there's a string. So we're going to have force tension as well. There's no surface on this object, so there's no force normal this time. So drawing our free body diagram, we have force gravity pointed downward, and then we have force tension pointed up. Moving to number 7, an object is suspended from the ceiling. Again, suspended is telling me balance forces. I know there's force gravity because there's always force gravity. And now I see that there's 2 ropes or 2 strings holding this object. So there's actually going to be 2 force tensions this time. So drawing my free body diagram, I have force gravity pointed downward, and force tension up at one angle and force tension up at the other angle. Force tension is going to point in the same direction that our rope is pointing in. Number 8, again, motionless. Therefore, our forces are balanced. I know I have force gravity. I know I have force tension because I see a rope and I see a second rope, so I have 2 force tensions. Doing the same thing I did in problem number 7, I'm going to do force gravity first on my free body diagram, and then my first force tension is going to point in the direction of my first rope, and my second force tension is going to point in the direction of my second rope. Let's take a look at number 9. The object is motionless. So motionless is telling us that our forces are balanced. Listing our forces, we know gravity is always there. We can see that this object is on a surface right here, so we're going to have normal as well. And then lastly, we see that rope, so we're still going to have force tension. It doesn't say anything about friction, so we're just going to ignore it in this case and say that there's no force friction acting on this box. Now drawing my free body diagram, I have force gravity pointed down. Since this box is on an incline, or it's on a slanted surface, I'm going to have force normal pointed up perpendicular from that surface. Then I have force tension pointed in the same direction as my string. Number 10, the object is motionless again. Motionless is telling me balance forces. I know there's force gravity. And then I see I have a surface right here, so I'm going to have force normal. But then I notice that I also have a second surface here, so I'm going to have 2 force normals this time. Drawing my free body diagram, I have force gravity pointed down. And then like we said before, force normal points perpendicular from the surface. So this first force normal is going to point in this direction, and our second force normal is going to point in this direction. So I'm going to go ahead and add those to my free body diagram. So 2 force normals, both pointed in different directions, but each of those directions is perpendicular to their surface. Number 11, the object is pulled by a force parallel to the surface with no friction and moves. Well, if it's being pulled by a force and there's no friction, that's going to tell me that my forces are unbalanced. Listing the forces, I have gravity, I have a force pulling it, in other words, an applied force. And again, I see a surface, so I have force normal. Drawing the free body diagram, I have force gravity pointing down. Force normal this time points straight up because it's a flat surface. And then my force applied is going to point in the same direction as this force vector. Number 12, the object is pulled by a force at an angle to the surface with no friction and it moves. So again, if there's not any friction, but it's moving in that direction, it's going to be unbalanced because it's going to speed up. Listing our forces like we did before, we have force gravity, we have force normal, and we still have force applied because we can see that right here in our problem. Drawing our force diagram, we have force gravity pointing down. Force normal is going to point up still because it's a flat surface. And then this time our applied force is at an angle. So we're going to have an applied force at an angle on our free body diagram. And it's going to be at the same angle that our applied force is here. Number 13, the object is pulled upward at a constant speed. Constant speed is telling me that the forces are balanced. The thing that is really important with these questions is that when we're talking about forces, it only matters what forces are in direct contact with this object. So right here, I see that I have a box, and this box has a rope directly attached to it on top. So I'm going to have force gravity because this box is always experiencing a gravitational pull to another object. And I'm also going to have force tension because I have this rope up above. So drawing my free body diagram, I have force gravity pointed down. And again, it just matters what forces are directly touching this box. I see that the force is being pulled down here, but the box is feeling the force being pulled up on it. So I'm going to have a force tension pulling up on that box. 14, the object is pushed by a force applied downward at an angle with no friction and it moves. Therefore, forces are going to be unbalanced, just like they were in a previous problem that had this. We know that we have force gravity, we see a surface, we have force normal, and then we see a force right there, so we have an applied force. Drawing our free body diagram, downward is force gravity. It's a flat surface, so up will be force normal. And then I see that this force is at an angle. It's at an angle downward. So therefore, it's going to have an applied force pointed downward. Number 15, the object is falling with no air resistance. So I can see right here these little speed signs or whatnot are getting bigger and bigger, meaning that it's accelerating, so it's unbalanced. What forces are acting on an object when it's in the air? Force gravity and air resistance. But in this case, there's no air resistance. So our free body diagram will just be force gravity. 16 is a very similar question, except this time it's moving at a constant terminal velocity with air resistance. So because it's a constant velocity, it's going to be balanced. We know force gravity is acting on our object, and since it's in the air resistance is now going to be acting on our object. So our free body diagram is going to have force gravity pointed down and force air resistance pointed up.